Hey friends, we're in Algebra 2 looking at section 3.3. We're going to talk about solving systems of inequalities by graphing. Our vocabulary phrase or our vocabulary term today is systems of inequalities, and we know what systems are. Systems are equations when we have more than one equation working together rather. And so a system of equations will be more than one of inequalities will be more than one inequality. Let me show you what I mean. So I can have x plus y is equal to, let's say, 7, and then maybe 2x plus 3y, or let me try minus 3y, get a little spicy here. 2x minus 3y is equal to, let's say, 9. And if I had to graph these, oh, nope, this is a system of equations. But if I wanted to make it a system of inequalities, I could do something like that, having two inequalities in x and y that I'm working with. So I'm going to get ready to graph these by solving each of these inequalities for y. So in this first one, y is going to be greater than negative x plus 7. You see what I did with my x. I just moved it over to the other side by adding its opposite. And over here, a little bit more involved. If I take my time and do the steps, I have a negative 3y is less than or equal to a negative 2x plus 9. But what I'm going to do is divide everything by a negative 3. And when I do that, I get y is greater than or equal to a positive 2/3 x minus 9 over negative 3, which is 3. And I wanted to do this. I was just going to do it off camera, but then I was like, oh, let me do it because I don't know if we remember when we divide everything in an inequality or multiply everything in an inequality by a negative, the sign has to change. So this is the situation that we're dealing with in this problem. And so I'm going to call this the yellow inequality. I'll refer to this one as the blue inequality, and we graph them. And so how would I graph a problem like this? You know how I graph any of these guys, any kind of a linear equation. I'm going to start off with the linear portion of it, which tells me that I got to start at 7 on the y-axis. And if this is hard, just know that we can talk about it in class. 1, 2, 3, 4, 5, 6, 7. So I have that there, and my slope is negative 1. So that's down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Let's assume that this is 1 and 2. I know I'm a little off, but just stay with me. And I have this line here, but wait, the line that we're talking about has to be dotted. And the reason why I know it has to be dotted is because y is not equal to, it's greater than that. So now I'm doing that to represent the dotted nature of it. And now what I need to do actually is to figure out the shading. So I'm going to shade above because y is greater than all of this stuff. And we've talked in previous videos about how I like to shortcut this particular step. You can, if you wanted to, choose a point and plug it in and figure out what side to graph. But anyway, we'll talk about that at a later time, again, if you're having trouble with this. Over here, the y-intercept is negative 3. So I'm down here at negative 3, 1, 2, and 3. There's that point, and my slope is rise 2, run 3, 1, 2, 3, rise 2, 1, 2, and run 3, 1, 2, 3. So I should be something like this. You know I'm being really sloppy, so this isn't exact. Notice that y is greater than or equal to. That lets me know that I have a solid line. And y being greater than means that I'm going to shade above this line, and we call this the blue equation, so I'm going to shade it above it in blue. And we get that. And so this is basically how we're going to do these problems, all right? So I totally did an example problem for free, but what I wanted to show you in talking about systems of inequalities is that the answer cannot be written kind of as a number or as a couple of points. It's like infinitely many points in the shaded region, right? So it's all of these points in this overlapping shaded region is what we're thinking about here, is what would be the solution to the problem, this little area here. Got me? All right, so that's what a system of inequalities are. Two or more inequalities, there we got a graph to get the solution to figure out where what points they have in common. So we got a couple over here that we need to work with, and I feel like you've seen a pretty decent example, so this should follow right through. You should probably, if you want to, you can try this on your own and then just check back with me in a second to see if I get the same answer as you. We're going to graph these as lines, right? This line should be dotted. This line should be solid. So if I start with this first one, let me give it a color. Let's call this the red line. If I start with this red line, or this red inequality rather, I'm going to start at positive 4. 1, 2, 3, 4. right there, and my rise is going to be, well, the slope is negative 2 over 1. So if I do rise 2, I have to go back 1, or I can go down 2 and forward 1 to get that positive 2 over negative 1 or negative 2 over positive 1, all right? And again, this should be reviewed, but if you find yourself in a position where you're like, I am feeling frustrated, let me know. Let me know if this doesn't work. We said this is a dotted line, so I'm going to do like that, all the way down, over 2, down and over 2, down and over 2, something like that, all right? So this is what the line should look like, and I'm going to be shading above because y is greater than this line. All right, so this is half of the answer. Next, we're going to graph the other one. Notice that, let's call this the blue equation. The blue equation, let's use this color. Notice that the blue equation has its y-intercept at negative 2, so we're down here. Its slope is positive 1, up 1 over 1, up 1 over 1. We see a point of intersection right there. And we know that this is going to be a solid line because of the less than or equal to. Could be equal to, so I'm going to include that in my graph. And then y is less than this line, so I'm going to shade everything below it. I'm going to shade everything down here. And the solution to this inequality is this overlapping area here. This next, so this is a lot like the one we just did. You should be comfortable with it. If not, let me know. This next one is a little bit more involved because it requires us to think a little bit deeply about this second equation. So let's go do the first one. The first equation, I'll call you orange today, or the first inequality. I'm going to start at a positive 1, and my slope is up 1 over 1, up 1 over 1. And I go ahead and I graph this, and you should know by now that this is going to be a dotted line because this is a greater than, not greater than, or equal to symbol. And then so I get my dotted line going through all of these points. And then I'm going to shade above because y is greater than. Above the line, y is greater than this line. But this next guy over here is a little tricky, and I need to think about him a bit more. So I have to ask myself, what does it mean when the absolute value of y is less than or equal to 3? If we've had class together, particularly Algebra 1, you'll know that right away I expect to write this symbol on this side and put the negative version of this number on the other side. That's my way of approaching this. That's like my little rule. And we talked about where that came from. But at this time, if you don't remember that, again, that's something that we can talk about. If this is the situation, in a sense, we've got an inequality to a conjunction inequality here, where negative 3 is less than or equal to y, or basically y is greater than negative 3, and at the same time y is less than or equal to positive 3. We know that the reported line or the associated line with this linear equation will be y equals 3. And this side would be y equals negative 3. And so those lines are going to be important, and they're going to be solid because the relationship with y is that it could equal 3 and it could equal negative 3. So if I refer to this as my purple equation, I'm going to make sure and go up to positive 3 and have that horizontal line. That's y equals 3. And then go down to negative 3 and do the same thing. You guys with me? I hope this is making sense. All right, so now that we've done that, I got to figure out where to shade. And you may have already intuitively recognized, well, if y is between the two, then we would shade between them, and that is exactly correct. These two conjoined together would give us a shading of in between, so I'm going to do that now. And so now our solution area is this little space here, going out to infinity in this direction. You guys with me? The solution area is the overlapping part that I'm trying to highlight right here. All right. So sometimes we're going to get that, and sometimes we'll have areas that don't overlap, that are separate regions. And one thing I'm noticing here is that the slope of both of these are the same, 1/2 and 1/2. And we remember the slope of the corresponding lines, the slope of the lines here. When the slope is the same, we know that the lines are parallel. So I can expect to have parallel lines here. All right, so let's get started. Let's look at this. I'm going to choose, let's just do blue here. So this equation, or this inequality, will start at 1, has a slope of rise over run of 1 over 2, and it has a dotted line as its line for this inequality. I'm going to shade above y is greater than. And the next one, again, we mentioned that it is they're parallel. This next equation has its y-intercept at -3, and its slope has to be the same. It too will be a dotted line. I think I put that in the wrong place. It too will be a dotted line such that we have this going on here. But this time we are shading below. Y is less than. Y is less than. And so we see that there is no true solution or no solution area for this situation. They're separate regions. Here we are with example 3, and we're going to write and use a system of inequalities to kind of represent the situation. So NASA chooses astronauts back in 1959. Size was important because of the size of their shuttle. NASA wanted men who were were at least 5'4", but no more than 5'11" inches tall, and who were between the ages of 21 and 40 years of age. Write and graph the system of inequalities that represents the range in heights for qualifying astronauts. So arbitrarily, I'm going to talk about height as y, and we know that the person that they chose had to be between 5'4" inches and 5'11". So y is going to have to be between 5'4" and 5'11". And I think it's nice to be consistent with just inches. So I'm going to do 64 for 5'4" and 71 for 5'11". Let's now talk about their age. To be quite honest, the age seems a little ambiguous to me. The age is between 21 and 40, but it says people who are between 21 and 40. It's kind of weird because sometimes we say that statement and we refer to something between 21 and 40. It would be really 21, from 21 to 40. So I'm going to honor what it says here against my better judgment and think that they only want people who are older than 21, which makes me wonder, are you talking about like 21 in a day? But people who are older than 21 and people who are less than 40. And so therefore we have to do less than and not less than or equal to. So let's let this axis be y. And so I'm going to just do that. And we know that means I'm not exactly starting from 0. Let's start at 60. And similar to the last problem where we had to graph y being between -3 and +3, here y is between, not that line, my bad, y is between 64, so this is 60, 62, 64, and 71, which would be right about here. And I'd shade everything in between this way. And that's our height equation portion. Give us that over there. And then between 21, our vertical portion or our age limit would be from 21, which would be about right here, to 40, which is here. But I'm going to have dotted lines. Kind of against my better judgment, but I think we can say that it's dotted lines here because they didn't say including. And then I'm going to shade in between these guys as well. There. All right. So I think the rest of this video will happen in another, the rest of this lesson will happen in another video. And so if you have any questions, let me know. If not, go on to the next video for the last part of the last example. Thank you guys.